Hey, I'm Dave. Welcome to my shop. Apparently there's a big Go Live button that I didn't click because I didn't know about it. I hit Start Streaming in the OBS software, but apparently that just gets it really ready inside of YouTube, even though when you're testing, this extra step is not required. Now I know. If you could let me know how my audio is right up front, I'd appreciate that because I had some issues with that this afternoon. The levels were a bit low. I want to make sure I haven't turned them up too high and over-peaked them and getting distortion and clipping and that kind of thing. I'll make sure I turn down my local mic. So what are we doing? I'm going to start at the top. We're going to be writing some code that is going to control some LEDs that are in the glass insulators above, and that code is going to live in the editor straight in front of me. I'll be editing the code. Every so often I will build and upload the code to the insulators to check our process. While I'm building and uploading, since that takes about 20 to 30 seconds, that's when I'm going to hit the comments and see what's going on there. So first thing I'm going to do is just build our code as it sits today before I even explain it, not run it, but just build it and make sure I can upload it. And that is what I'm going to hit the comments. All right, levels are good. Audio is just right. That's good to hear. Thank you very much. Audio sounds Gucci. Audio is good. All right. I have a couple of different views here, and when needed, it can be just me and so on and so forth. I also can bring on the dogs, but the dogs aren't here, so showing the dog bed doesn't really do much, but if they were here, it'd be interesting. And then back to the standard setup here where I've got the code and the insulators and me. All right, we have succeeded. We have uploaded. We've done everything we needed to do. Let's take a quick little tour of the code. The beat effect base class is a class that knows really how to draw into the LEDs in the LED chain that forms the lights that fits in these insulators. It provides a whole bunch of things, but all we're really going to use is set pixel, fill ring, some real basic drawing things like that. There are two methods that we care about that we're going to implement in our derivation of this class. One is draw, because sometimes we're going to want to draw our own stuff. The other is handle beat. It's also another opportunity to draw, but what handle beat does is it's called whenever there is, you may have guessed, a beat in the music. So the base class does all the analysis, analyzes an FFT, does the whole bit. But it happens all in the 50 times a second in the background on another thread, and then the results are pushed over to this thread. So it doesn't even use any CPU in our case. Well, it does, but it's on a different core. Once the beat command actually happens, you can go in and you can draw to the strip, you can change state, you can change colors, do what you need to do. So we have handle beat now, and we have draw now. Draw, all it does is calls the base class, and then every frame fades the strip to black by a little bit. That means, say we go and we fill an insulator with blue. It'll be bright blue, and then it will fade to black. Over the course of, well, based on the constant I'm using, maybe a half second. We'll see. Handle beat, this is the function that's called whenever a beat happens. First, I call the base class, just good practice, I imagine. What I do first is I start with a number -1. I then pick a number between 0 and the number of fans, or the number of insulators, the number of glass pieces that I have. And if that's the same as the last insulator we drew, I keep doing it. I just keep doing it until it's not the same as the last insulator that we picked. As soon as I have a new eye that is not the same as the last insulator, I go and use that. And we're going to fill the ring pixels with a random saturated color into insulator number I. What else is of interest here? The base class has a couple parameters in terms of where the VU meter must cross. So you could set this to say you have to go all the way down to 0.1 and all the way up to, it goes from 0 to 2, 1 being the middle. So you could say you have to go all the way down from 0.1 to 1.9. I'll call that a beat. Only when it spans the entire dynamic range of my stereo, that's a beat. That would be the overkill. You could also say anything around 1.0, if it just even twitched around 1.0, but that could be a singer's vibrato, so you don't really want that. So it takes a certain amount of fine-tuning to get what the gap is and where it should be placed. I also give you control over how long that beat must be before it's considered a beat at all. I'm going to dial up the brightness a little bit here. 32, 255ths. We'll upload. Let's see what's going on in the comments. Hey, chat. No complaints. Eric Bailey says, maybe you should have created a random list of insulators so you didn't need a loop. You would still need the loop unless you were shuffling the list, right? But you could keep a list of the ones you had so far picked, and that would be good because you would then at least not duplicate them. So You could say of the 5, I'm going to have 5 insulators, as we do. Oh, let's see what we got here. Let me just try some random music for a few seconds here and see if it tracks the music. Wait a second. Before I turn up the audio, I've got to make sure that, no, that's not going to work, because as soon as I play music, I'm going to turn up the music and I'm going to hear the web stream, which I don't want. What if I pause it? Does that work? Or does that pause everybody? That'd be bad. Let's try it. Okay, it's tracking good. Now you may have noticed it's only tracking longer beats, and I have it set right now. Let's go back to check the code. Don't guess. I have it set, don't go to any beats that are less than a full 1/10 of a second. And I think if you do the math, if you're at 120 beats per, 120 beats per minute, it's like 2 beats per second, 2 measures per second, 1/8 of a second is 0.125. That would be an 1/8 note. So yeah, this should be catching like 1/8 notes. Or no, this is just full quarter notes, actually. I'm mistaken. I'm not a musician, so I forget that quarter notes are like 1 full beat in a measure or something weird. So I think it's 0.125, so this should be okay, but we can shorten it up. We'll go 0.08 of a second. Try this one more time, a different song, and then we'll try changing it so that we never repeat insulators by doing, as I believe it was Eric Bailey, if I got the name right, said, and keeping a list of which ones we've already used. I think I'll use just to make it interesting, a C++ deque for that. I know it's a 5-item array. I could probably just keep a 5-item array, but what fun would that be? Besides, what if I wanted to do infinity less 1 insulators? Actually, no, it's just 0 and infinity, right? That's the rule. All right. All right, play some music here, see what happens. Yeah, it's tracking well. It looks weird to me when I look at it in OBS because, you know, there's a delay, obviously, some latency of maybe even, let's say, 300 milliseconds. Well, that's a lot when it comes to audio. If you're trying to keep track of in your head whether a beat is synchronized visually, I think 300 milliseconds is a long time. I've always made the guess that humans are used to the sound coming later because, say, you're standing 100 yards from somebody and you shout, well, even 100 yards is long, 30 yards, let's say, and you're shouting at the person. Their mouth is not going to be synchronized with the audio that's going to arrive late. So I think your brain is pretty well equipped with audio arriving late. Audio that arrives before the visual signal, I don't think your brain likes that. I can prove none of this, but it feels right. So what we're doing now is we're just making the last insulator. We don't want that. We'll get rid of that. We get rid of the I equals last. Get rid of all that. And all we know that coming in is we're going to need an I to set to something new. So let's take a deque, is it? A deque. And we'll just do have integers, and we'll call it lit. And this will be our list of things that are currently lit in the insulator chain. So the first thing we want to do is in the handle beat, we want to make sure we don't have too many items already predetermined in our list. So we're going to throw away items until the list is a manageable size. We'll do that. So we'll say, well, the lit size greater than equal to numFans less 1. I think I have to do less 1 because if I don't, doesn't that just cause it to, if I did the exact same number as the number of insulators, it would generate the first pattern and then just follow that forever. And maybe that's what you want it to do, but I don't really want that. So I'm going to go to the size of the list less 1, and that one, there was always room for a dupe, right? I can always have room to find it. I guess I could pop off the front or the back, but I'm going to pop off the front and push onto the back. This is the number I'm going to search for. We're going to do a do loop just like we did last time. We'll let I be a random number between 0 and the number of fans. Bonus points to anybody who noticed that when I actually committed the bug of putting num LEDs here in an earlier test, I even said that I was going to do that, which was funny because then I did. I not only said what bug I was going to commit, I then wrote the bug. So what do we want? We want to say when the lit end, which is really STL shortcut for null or not found. End being it's not in the list, it's at the end of the list. It's never really fit well in my head either, but get used to it eventually. Where are we going to search? We're going to search using the standard find algorithm from lit begin to lit end. We're going to search for I. Lit dot end. That should make it happier. Okay, now we fall through. By this point, we should have a new I that is not in the list above because we've just we've iterated and randomly picked a new number until that number was not in the list. So when we fall through, we should have a new number. So we'll push that guy in the front. Then we will fill the ring with a random color. In insulator I, we've got our fade. We're calling our base classes. We've got our deque. Don't see any big obvious errors. Let's see if this works. We'll see if we can build first. But all right, off to audio. Do-do-do-do. Thanks for those of you shouting out the kind words in the list here. Or not in the list, in chat, I guess it is. What if I can speed up the upload of this? I've already got it set to 1.5 megabaud, which to a guy who grew up with like 110 and then 300 and 1200 and 2400 and 14.4, 1.5 megabaud seems really fast for a serial connection. So I don't want to be greedy, but it does take a while to upload these larger images. By the way, I'm not playing the drums on the desk every time I compile. It's I'm checking the insulators that are up there, I guess. Let's see. Get some music going here. I can hear myself talk. That's not what I want, though. Cool. Now let me see if I can tighten this algorithm up a bit so we can get some shorter beats going on. The most aggressive I can be is actually, I believe, 1.0, 1.0, and we'll say 1/100th of a second. That's a beat. So this should beat like, and flash and cycle and pick a new insulator for pretty much anything that happens auditorily. All right. Yeah, how's Dave making the YouTube Content ID guys upset, but I'm trying not to. Let's see. That worked pretty well. What can we else try? Somebody had suggested earlier that we make this a spectrum analyzer in the comments. That what we need to do is, if you think of a 5-band spectrum analyzer with the, the bars that go up and down, instead we don't have bars that come up and down. What we can do is we can cycle the brightness of each of the insulators, and we can do the color standard rainbow, make a red insulator and a yellow insulator and a green and maybe a cyan and a purple. We'll do those, color them, and then draw them the relative brightness of the audio in that frequency band. How on earth are we going to do that? Well, we're going to use an FFT, and of course, I mean, it's trivial. Yeah, I just happen to have that code handy, so that's why I say it's trivial, because that's what mathematicians say when they already know the answer. It's trivial. I don't really know the answer. I have a rough idea, though. Let me see. Give me a moment while I get ready to write some spectrum effects. How ironic. All right. If I'm not mistaken, this can actually be done pretty simply. So I'm going to hard code to 5 insulators. I know that's kind of cheesy, but I don't want to make a variable color table this time around. So what we're going to do is we're going to take a new class, insulator. We'll call it spectrum effect, and we'll derive from LED strip effect. LED strip effect is the very base effect for LED strips that I've got that gives you things like set pixel, draw pixel, time to draw now, things like that. It does color blending and so on. So one assumption I'm going to make here is that you've got at least as many bands in your spectrum analyzer. Not enough bands to cover all insulators. So what I'm saying here is static assert, by the way, is like compile time assert. Raymond Chen, I think it was, did a pretty clever compile time assert, or maybe it was Bob Day, I don't remember. One of them did a very clever compile time assert by, I don't know if it was like divided by 0 with a pound define or something weird like that, that if your assert didn't work out properly, it would cause the compiler to get angry and stop. This is now built into the C language, so we don't have to resort to such craziness. So we're going to say we got 5 bands. We're going to start with band 0. We go to band. And by the way, before anybody gets smarmy in the code comments here, or in the comments, I should say, coding live is not the same as, yeah, see, I can't even think and talk at the same time, let alone think and do anything entertaining, so draw ring pixels, I remember that much. By the way, fan is the same as insulator. The first thing I ever wrote was, not the first thing, but the first thing I wrote that did a bunch of concentric LED ring drawing was for fans in a PC case. And for that reason, everything in here is going to refer to fans and fan size and the number of fans you have. Later, I went to insulators as the next effect I was writing, and later I'm going to do Christmas trees, which are crystal pyramidal trees. So the names change, but until I find like a generalized name like cylinder of circles. So I have a thing called G peaks here, which is you have for each band, you have the VU peak that has occurred at that band. You also have the ratio, which is if you take the denominator of where the VU has swung. Let's say the VU has never gone anywhere outside of 0.25 and 1.0, so that's a 0.75 range. Then I look at the ratio of that 0.75 that the VU is currently up, and I say, well, that's an interesting number because it probably means how loud it is relative to the background and the current maximum volume. And we call that the ratio. So I can grab that by going thusly. And we'll draw the color. I'm going to switch the order around. Which way do you guys see it? Yeah, you see it this way. So the base is on the left, right? Because that's usually what you do. So instead of going lowest bands forward, because lowest is your smallest one here in this case, because the CPU is actually the farthest away from the camera. It's just where they're connected, so that would be the 0. Now we want 0 to be on this side, so yeah, it's numberless. It'll fade a little faster than we did. We did 1500 on the last one. We'll do 1000 on this one. And then we can delay, let's say, 20 milliseconds. So we draw at roughly 50 frames a second. That's as fast as our audio processes. I've got that capped to 50 right now as well. So. What does it not like about this for? Expect a declaration. Oh, I hate these. This means I have some kind of like stray comma or something horrible. Pardon me while I figure out my build problems. We'll call it EX. That's what Microsoft would do. EX2, EX. Don't have a constructor, so I don't have to change that name. I should probably put this inside of a method, right? That's going to cause me no amount of grief. I've been going back, I've been doing the 50 languages project, and it's really throwing me because I'll work in C# for a couple hours, and then I'll come out in C++, and I'll put my publics in the wrong place. And then I'll start working in Pascal or something horrible, and I'll just start putting begins and ends inside my C. My brain is not good for going back and forth really quickly. It is huge momentum. It's not neither good nor bad, but it's got a lot of it. So this is actually an exercise of a draw, right? Virtual void draw. Now I need a color. So we'll say this is in a header file, so we're gonna have to move this. But for now, we're gonna go red, and then we'll say yellow. Green. What did I say? Cyan, maybe? And purple for the treble. Might have to include sound analyzer here because I'm talking about those peaks. They are defined in the sound analyzer. There we go. That's what it was unhappy about. Let's see if this compiles. Well, it links. That's a bonus. Now, this is also going to be a very fast reacting effect, so it's probably been driving you crazy over my head here if you've been watching it. I don't have an easy way to turn it off. All right, so it is loaded, and this thing really going to work? This is like 4 lines of code. How can it be this simple? I got to draw, I got to fade, I'm drawing ring pixels, I'm picking a color, I'm going through all the bands, I'm drawing into each of the insulators. Yeah, well, maybe it is that simple. We'll find out. I need to go to my effects file and replace that beat effect with the new Spectrum Effect EX. Why did I choose glass insulators? Because I thought they would look really cool, and my grandpa, I used to collect them, and then I was thinking, what else could I do with these things? And I noticed that the one website that I shop at had rings roughly the same size as the inside of the glass insulators. Well, look at this. We actually got something cool going on here. Can I get some music maybe? Let's see. There we go. Works pretty well. Also works pretty well with voice because I have the actual band set down pretty low so that it's like 60, 200, 500, 1000, and then anything above 2000 is roughly where my EQ breaks are. So that might be a good thing to leave it at for this particular live stream. So I appreciate you guys all stopping by. It's the first time I've ever done it, and I have no idea what this is going to look like. I'll go back and I'll watch the video, and I'll post the thing later so that others can watch it as well. But we'll see how it turns out in terms of production quality. And yeah, I can do the Just Dave thing, right? There we go, Just Dave. So we'll see how it turns out in terms of production quality and sound and everything else. Sounds like it was working okay. Hopefully it wasn't too bad. So in the meantime, in between time,